Hi guys, I'm Ryan, and in this video we're going to cover IB Calculus topic 5.11, which basically is complicated definite integrals. And if you're an AASL, AAHL, you need to know this, and if you're an AIHL, you need to know this. If you're an AISL, you do not need to know this, okay? So, in chapter 5.5, we covered some simple definite integrals, okay? So why is this a simple definite integral? Because you can see it's addition of two chunks addition, meaning we can break this up into two integrals, and for each of these integrals they are easy, right? So this is called the simple case, which we covered in 5.5. If you do not know how to do this, you need to look at the 5.5 video, okay? So in this video we're going to cover some more complicated cases, okay, which requires you to use the integration by substitution that we talked about in video 5.10, okay? And this is a complicated one because you can see this is a composite function, right? So it requires some substitution. Okay, just to refresh your memory, we have to do integration by substitution, and the steps are here. These are the identical steps to what we have covered in 5.10. So if you don't know how to do complicated integrals, not complicated definite integrals, okay? If you do not know how to do normal complicated integrals, you need to look at video 5.10, okay? So now we're going to combine the two topics together, 5.5 and 5.10, right, to do some complicated definite integrals. Definite integrals are the integrals with these numbers in these positions, okay? So without further ado, let's explain how to do this with a past paper question, okay? So this question is taken from May 2022 AASL Time Zone 1 paper 1, okay? So no calculator allowed, okay? So we basically need to show that this complicated definite integral is equals to this, okay? So how do you do that? Step one, we need to let u equals to something, right? Step one. So step one, I'm gonna let u equals to sine x, okay? If you're asking me, hey Ryan, how do you know u is equal to sine x? Why isn't it u equals to 8 sine x or something like that? Well, the quick answer again is by experience, okay? However, there are notes, or there are tricks to do this, okay? How do you know u is equal to sine x? Well, remember in 5.10 I said you want to try to substitute u as something in the brackets, right? So looking at this question here, what looks the most complicated? This thing here looks the most complicated, right? So let's rewrite that. We can rewrite that as, what can we rewrite this? How can we rewrite this? We can rewrite as this, right? So 4 cosine x, and then times 8 sine x, okay? And then this whole thing to the power of 6, right? dx. So if we follow the general rule of thumb, replace stuff, do u substitution with stuff inside brackets, you can see that this chunk is inside the bracket, okay? So we want to replace this with u, okay? And after substitution, we and then we gotta find du over dx, right? So finding du over dx, we know sine x becomes cosine x, okay? So dx is equals to du over cosine x, okay? So now we substitute this dx into here, right? So what we get is integral of 0 to m 4 cosine x, okay, 8 sine x to the power of 6, and then du over cosine x, okay? And then we want to substitute this into here, right? Or sorry, the u into here, right? So let's just erase this chunk here. Let's just erase this chunk here and then replace it with u, okay? So how do I know u sub is, how do I know that I need to substitute u with sine x, right? Okay, so the first reason is because sine x is in the brackets, and also the second reason, okay, if you can think 2 steps ahead, if you're here and you can think 2 steps ahead, okay, after substitution, do you see how this cosine x and this cosine x will cancel? After this cancellation, okay, we're gonna have a 4 u to power of 6. 4 times 8 times u to the power of 6, which is going to be a very simple integral, okay? So that is what you're supposed to be thinking of, okay? So because here we can cancel the cosine x, we know this is the correct substitution, okay? So then what do we have? We have 4 times 8 is 32, and then we have cosine x gets canceled, right? So this here gets canceled, okay? So we get 32 u to the power of 6, okay? Now at this step, I tell all my students to remember to put a marking here, okay? What's the marking that you need to put? This is x equals to m, and this is x equals to 0, okay? Why is this important? Look, okay? Here's why it's important in the next step. Normally, if you were to do this definite integral, what will you do? Oh, 32 u to the power of 6, okay? So the integral will be 32 over 7 u to the power of 7, right? Okay, simple. And then what you would do normally is substitute this m into here, and then this 0 into here, and do subtraction like this, right? like this. So 32 over 7, okay? And then m to the power of 7 minus 32 over 7, 0 to the power of 7, right? Substitute it in, okay? This is completely wrong. Do not do this, okay? Wrong. Okay, why is this wrong? Because this is x equals to m and x equal to 0. Not u equals to m, u equals to 0, okay? It is x equals to. Now, what do we have here? We have u, so we're not supposed to substitute these numbers into here, okay? So there's an extra step we need to do, okay? What we need to do is, so this is the correct case, we need to do 32 over 7, okay? Replace the u, replace this u, okay? Back with this here, because this here has x, right? So substitute it with sine x, okay, to the power of 7, okay? Then we can get 32 over 7, okay, sine m to the power of 7 minus 32 over 7 sine 0 to the power of 7, okay? So then it is legal for us to substitute this here and substitute this here, okay? And what is the result? The result is just 32 over 7 sine m to the power of 7, okay? Why is this gone? Because sine 0 is 0, right? So 0 to the power of 7 is 0, 0 times 32 over 7 is 0. So this we can basically ignore, okay? So the final answer is this, and as you can see, it matches with what the question is asking us to do, okay? So this is how we can do some complicated definite integrals with integration by substitution, okay? And that's it for this video. If you guys like the video, please give the video a thumbs up. If you guys have any comments, please put it down in the comments down below, and subscribe to our channel for more video updates. Thank you.